Now that we have some basic vocabulary about circles, we're going to discuss central angles and arc measures. But before we go too far, right, you should know that it is critical, right? It is critical that you pay particularly close attention to the basics of circle logic, right? It will serve you well in this section and the rest of the sections to come throughout the year. So stay tuned and stay focused. As you recall, the central angle is an angle with its vertex at the center of the circle, and its two sides are radii. That's the plural of radius. The sum of all central angles in a circle is 360 degrees. Now this is the first big deal that we want to pay attention to. The sum of all central angles inside of a circle is 360 degrees. Now up top, we have an example. Angle ABC is a central angle. Why? B is at the center of the circle, and then the sides of the circle, right? The sides are segment BC and segment BA. So don't forget that these are congruent pieces because they're radii. And the degree of the arc formed by the endpoints of the circle are equal to the degree of the central angle. So the degree of the arc is the degree of the central angle. So if this is 84 degrees, then the degree of the arc is also 84 degrees. So arc, right, the measure of arc AC is equal to 84 degrees. Now, what about the measure of the arc ABC, right? That major arc. Well, if arc AC is 84 degrees, then ADC is going to be 360 minus 84 degrees, right? Or 276 degrees. So this is going to be 276 degrees, right? This measure all the way here is 276 degrees. So as we cruise into angle 1, just some important pieces. First, let's remember that a diameter is going to be equal to 180 degrees. A major arc is going to be greater than 180 degrees. A minor arc is going to be less than 180 degrees. This is always 2 letters, and this is always 3 letters. It's going to be helpful. So, for instance, if I look over here, I know that this is less than 180 degrees because it's a minor arc. It only has 2 letters. This has to be an angle right here. This is a minor arc, so this is going to be less than 180 degrees. This has to be greater than or equal to 180 because it's 3 letters. Greater than or equal to 180 degrees because it's 3 letters. On the arcs, I can tell. On the angle, I'm not sure. I'm going to have to look. Then the other things, remember that we have vertical angles, right? They're always congruent. Right? Vertical angles are always congruent. And we're just going to have the fine art of addition and subtraction here. So let's dive in. I look at this central angle right here. It's vertical to this central angle right here, so that's 21 degrees. Now I know that segment JL, right? JL is equal to a diameter, which is equal to 180 degrees. And so is KM. So I think about this and I say, well, if this is 180 degrees, then 180 minus 21 degrees is going to give me what's left right here. So when I do the subtraction of 180 minus 21, I get 159 degrees. So this is 159 degrees. So the angle is 159, so is the arc from K to L is also 159 degrees. Likewise, if this essential angle is 21 degrees, then the arc measure for JK is also 21 degrees, and this is going to be 21 degrees. And then I have, this is vertical to this right here, so this is going to be 159 degrees as well, as is the arc out there. So now we just start adding and subtracting, all right? And we start looking at what they're asking. So for the measure of arc JK, that's right here, right? So JK is 21 degrees. Next, we go to angle JNM. It starts at J, heads into N, comes out to M. So that's this angle right here. So that's 159 degrees. Arc KL, minor arc KL, is going to be starting at K, traveling towards L right here. So that's this arc. We already said that that was 159 degrees. And then we have major arc JKM. So let me just erase a little bit and get neatened up. Okay, so if we start at J, go through K and stop at M. So through K is this way, and we're going to stop at M over here. So that's JK all the way to M. Well, there's two ways of going about that. That could either be the 21 plus the 159 plus the 21. So I could take 21, add the 159, add the other 21. So that's really 42 plus the 159. That would give us 201 degrees, right? This is 201 degrees. Or remember that basically, if we want all of this, what we don't want is any of this. So 360 minus 159 is also going to give us 201 degrees. So sometimes I can do it by adding a bunch of stuff, and sometimes it's just as easy to do some subtraction of a bunch of stuff. Okay, now that we've tidied up a bit, let's take a look at major arc MKL. Starts at M, goes through K, ends at L. Starts at M, goes through K, and ends at L. So if it ends at L and goes through K, it's going to have to go all the way around like this. Now this is going to be one of those where I'd say, you know what? I guess this is best phrased as 360 minus 21. That's the only thing that's not included. So that's going to get us 339 degrees. And that's that. So before we get going too far, remember to fill out the diagram in full first. So let's take a look at number 2. I know that W to U, okay, this is a diameter, which means that that's equal to 180 degrees. So this is 180 degrees, and this is 180 degrees. So use that to your advantage. The other thing that I notice is that I'm given the measure of this arc out here is 72 degrees. This is 72 degrees. So this is 72 degrees. And now again, this whole thing is 180. So the measure of angle SXT and this arc right here is going to be 180 minus 87 minus 72. So let's do that subtraction. And as you can see, I get 21. So what we have here is this is 21 degrees. And so is the arc it contains. Over here, outside, arc TU is going to be 87 degrees. And if this arc right here is 72, then this is also 72 degrees. Now from here, we're just going to work smart. And what do I mean? I mean, we have to start looking at some other items. So if we look along SV, this is also another diameter, which equals 180 degrees. So we all already have that this part's 21, this part's 87. What's this part? Well, that's going to be 180 minus 87 minus 21. Grab your calculator and do a little subtraction. What do you get? If you're waiting for me, I hate to call it, but I'll call it what it is. Being lazy. Do the subtraction yourself. You should get 72 degrees. So I guess we'll neaten this up and fill that in. Now, was that the hardest way to do this? Well, perhaps. Right here, we had that these were vertical angles, So whatever this is, and we already had that this was 72. I guess we didn't really need to do any subtraction, but it still checks out. Next, we'll take a look at up here, right? This entire piece here is vertical with this entire piece here. So if I take 21 plus 87, I'm going to get 108. So this must be 108 degrees. And this is also 108 degrees. How else could we have gotten this? We could have thought about this diameter right here, and that this is 180, so 180 minus 72 is also 108 degrees. So that checks out either way. Now, we just need to look at what they're asking, right? We've filled out the diagram, right? Fill out the diagram, then go answer the questions after. So first things first, the measure of angle UXV. Angle UXV is going to go from U to X to V. That's right here. That's 72 degrees. The measure of minor arc ST, that's right here. That's 21 degrees. The measure of minor arc WV, remember these are less than 108 degrees and less than 180 degrees by definition. W to V is right here. That's 108 degrees. The measure of minor arc TW, right? Less than 180 degrees. TW goes from T all the way to W. So that's going to be 72 plus 21, which is going to be 93 degrees. And last but not least, we have a major arc right here. This is greater than 180 degrees. Starts at T. Right, so we're going to start at T. We're going to end at W, but we have to go through V. So that's all of this. Now, how you want to answer this is up to you. You could add 87, 72, and 108, or you could just subtract 72 and 21 from 180. So 180 minus 72 minus 21 will yield us an answer of 267 degrees. Or you could add 87, and I'll do this in green, 87 plus 72 plus 108, and also land at the same idea of 267 degrees. So either way, that's 267 degrees. Fill out the diagram first, the rest is easy. And let me just put in one correction, my bad, this was 360, right? All the way around is 360, so if I subtract what I don't want, which is this, then I'll get what's left. Little faux pas with the 180. My apologies. Now we move on to some algebraic pieces, but same thing, same logic holds true. Fill out the diagram a little bit, see what's going on here. So they want me to find the value of x, and I see that 18x minus 2 is this angle, or this arc measure up here. I also notice this, that I have, this is 103 degrees, so is that whole piece right there. So 18x minus 2 plus the 15 is worth 103 degrees. So if I combine my like terms here, I'm going to get 18x plus 13 equals 103. Subtract the 13 from both sides, and I'm going to get 18x is equal to 90. I'm going to divide by 18 on both sides, and I'm going to get a value of x of 5. So x is equal to 5. If I double check that, 18 times 5 is 90. And I'm going to subtract 2, which is 88. And if I take 15 and add it to 88, what do I get? That's 13. Carry the 1. 8 and 2 is 10. That's 103. Check. We're in good shape. The algebra versions almost work out even easier. Now, if I look at number 5, what do I notice about RT? RT is a diameter, and that diameter is worth 180 degrees. So this is worth 180. So 15x minus 26, right? That portion plus to 26 is equal to what? The diameter. You solve. For number 7, again, I see that this is a diameter. I also see that this is a diameter. I also notice that this angle right here is vertical to that angle right there, which makes arc AD the same as arc BC, right? The measure of arc AD, minor arc AD, is equal to the measure of minor arc BC. If their arcs are equal, then so is the algebra between them. So 8x plus 12 should be equal to 10x minus 22. You solve the rest. Number 9 starts to get maybe a little bit more complicated, but don't be fooled, right? So let's just kind of take a walk through it slowly. First thing that catches my eye is that this is 90 degrees, which makes the arc VY 90 degrees. All right, anything else that we know? Well, I really don't know anything else, and I don't see any vertical angles, but I know that I have every arc, right? There's 1, 2, 3, 4 arcs, and I know that all of the arc measures equal 360 degrees. So 8x plus 21x minus 12 plus 10x plus 9 plus 90 equals 360. Again, this is my first arc, my second arc, my third arc, my fourth arc. Right? This one was 21x minus 12, and this one was 10x plus 9. So all I need to do is combine like terms and solve for x. This isn't really that complicated in terms of the algebra, and then at the end, for numbers 8 and 9, we're going to have to solve for a few more things. So what I mean is once you have the measure of x, they're going to want the measure of arc WX. Now I know that's less than 180 degrees. And where is WX? WX is right here. So once you have x, right, substitute in the value for x, and then evaluate that answer, and that's what goes right here in terms of, right, degrees. So don't forget, these are all measured in degrees, degrees, degrees. And YW is going to be 90 plus, right, 8x. So 90 plus 8x, where I'll know what x is once I'm done with the algebra. That's going to go right here. YX is right here. Just substitute into here. So that's that answer. And then VXW. VXW starts at V, goes through X, ends at W. That's all of this. I guess I'm just going to say 360 minus 8x degrees is going to be my answer. All I need to know is what's that. So 360 minus whatever 8 times x is going to be that measure right there. And remember, it should be greater than 180 degrees because it's a major arc. Okay, so you might want to press pause and handle these questions because we're going to shift gears a little bit now. Okay, so press pause and complete numbers 1 through 9 now. Next, we have our arc length formula. And we're going to borrow this from our vocabulary sheet. So the length of an arc, right, is going to be x times c, where c is our circumference. X is the degree of the measure of the arc, divided by 360. Now, let's not make too much of a big deal about this. If we took a circle and we divided it into fourths, this is 1/4 of the circle. This is 1/4, this is 1/4, this is 1/4. So the distance around the circle, right, that's its circumference. And so the distance around the circle is its circumference. So let's just say the circumference, for example, let's say the circumference was equal to, oh, I don't know, 24 meters. Well, what's 1/4 of 24. Isn't that 24 divided by 4, which is equal to 6? So I would say, well then, this piece right here is 6 meters. And this is 6 meters. And this is 6 meters. And this is 6 meters. Wouldn't that make sense that the proportion, right? The proportion of the arc, is the proportion of the circumference, right? So let's go back to this formula. That's all we're saying. If you take this part of the formula, that is referring to the proportion of the circumference, right? We would say something like, well, 90 degrees over 360, that's my x over 360 times 24, which is 1/4 of 24, which is 6. That's all we're saying here. This is just a very formulatic way of saying it, all right? So this is just logical, right? This formula makes sense. Let's push on and apply it. Again, fill things out first, all right? So I know that NR is 8 feet. So this is 8 feet, which makes this 8 feet, which makes this 8 feet, which makes this 8 feet, all right? NR is a radius. This is a radius. So all of the radii are congruent. All right, so let's just erase that now that we understand. We're going to need this for our circumference formula. So keep in mind that circumference is equal to 2 pi radius, or circumference is equal to diameter times pi. So circumference is going to be equal to 2 times pi times that value of 8, or circumference is going to be equal to 16 pi. So let's hold on to that part, because remember, our arc length is equal to x times the circumference divided by 360. So we already have the circumference portion. Next, we need to use the idea of 162. So if this is 162, then this is also going to be 162, because this angle right here is congruent to this angle right here because they are vertical. Now, keep in mind that this is a diameter right here. So 180 minus 162 is going to yield me this little arc right here, which is going to be 18 degrees. So this is 18 degrees, 18 degrees, and 18 degrees. Okay, they want the length of arc NMP. So starting at N, going through M, and stopping at P, all the way there. So I guess that's going to be 360 minus this 162. That's the only thing that's not in the game, right? So the measure of arc NMP is going to be 360 minus 162. And that's going to get us 198 degrees. So that 198 plus this 16 pi is all we really needed. The length of the arc is going to be equal to the measure of the arc, x, 198 degrees, divided by 360, right? Remember, this is the proportion of the circle we're talking about, times the circumference, which is 16 pi. Now, I know the formula showed it all like that, so we'll leave it like that. But first, I'm going to deal with this subtraction to get the proportion. So I got 198 divided by 360 gives me a little over half the circle. So that's going to be 0.55 times 16 pi, which is approximately 27.65. And our units are in feet, so this is feet. It's not square feet because this is a distance, right? And distance is a linear measurement. Proportion times the circumference. Now, this answer is if you use the pi key on the calculator, or if you use 3.14, you're probably going to get 27.63 feet. Okay, and both of these answers, right? This answer is more accurate. This answer is fairly accurate. They're both reasonable answers. Okay, let's try that again. Again, work smart, not hard. I have that this angle right here is vertical to this angle right here, right? Forms an X. So 85 minus 59 will yield us this arc and this angle right here. I get 26. I'm going to put 26 degrees right here, right here. And I'm also going to throw 85 out here and 59 out here. Okay. Now what? I know that this is a diameter. So 180 minus 85 is going to give us 95. So this is 95 degrees and this is 95 degrees. And because these are vertical, that's 95 and that's 95 degrees. Okay. I also know that JH is 21. From J all the way to H is 21. So this is our diameter. And remember that circumference is equal to diameter times pi. So the circumference of the circle is 21 pi. That's helpful. Now I want to know the arc measure of KJG. So starting at K, going through J, and ending at G. That's this whole thing right here. So that's going to be 360 minus the only piece that wasn't included was 26. When I take 360 and I subtract 26, I get 334. So this is the arc measure, right? That's the measure of arc KJG. So the length of that arc is going to be equal to x over 360, the proportion of the arc, times the circumference. So the proportion of the arc is 334 divided by 360 times, we said our circumference was 21 pi. Now I'm going to deal with the fractions. So 334 divided by 360 is going to be approximately 0.292, all sevens. So let's call it 928 times 21 pi, which is going to yield us approximately 61.21 inches, because they said inches. That's 61.21 inches approximately. That is our arc length. Now again, some of us are going to say, well, this is 0.928 times 21 times 3.14. And if you do it that way, you're going to get approximately 61.19 inches. Again, this answer's okay. This answer's okay. This one's just slightly more accurate because it's using the pi key on a calculator. For our last example, again, I'm just kind of looking really quick here. I see that this is a diameter, so this is 180 degrees. So this arc QR is going to be 180 minus 128. All right, that's going to yield me 52 degrees. So right here is 52 degrees, and out here on the arc is going to be 52 degrees. Now I have a nice little vertical relationship here, so this is going to be 52 degrees, 52 degrees. Out here I could put the 128, and then my last piece is to get this arc right here, or this central angle I should say. So I know that this is 31 right here. I know that this is 52 right here. So 180 minus 31 minus 52, because this is a diameter, will yield me that last piece. And that's going to be 97 degrees. So this is 97 degrees and 97 degrees. And doesn't this look like a little bit more than a right angle? Okay, so we did all of that because we need the arc TS. I needed that arc. Now I go back up here. WS is 4.5 millimeters. So I go find WS. That's this piece right here. That's a radius. I just need to know if it's a radius or diameter. So circumference is going to be equal to 2 pi radius, because they gave me a radius. So that's going to be 2 times pi times 4.5, or 9 pi. That's my circumference. I need my circumference, and I need my arc measure. So the length of the arc, TS, right, is going to be the proportion of the circle it occupies, so 97 out of 360 times my 9 pi. And the rest is just doing the calculation. So I get 97 divided by 360. I get 0.2694 repeating times 9 pi. And when I multiply that times 9 pi, I get an answer of 7.62, approximately 7.62 millimeters. So that's a reasonable final answer for the length of TS. Now, what if I had used the 3.14? If I used 3.14 in place of pi, I would have got approximately 7.61 millimeters. So both these answers are very, very close, and both are legit. Okay, so now you complete numbers 1 through 15. Of course, you should have already hit pause and completed 1 through 9 already. And that'll wrap it up, okay? Work smart, right? Work smart, not hard, right? And maybe I should learn how to spell smart. S-M-A-R-T, okay? Give me a little break. It's been a long day. See you soon.